Since December, we've been watching our coho salmon grow from little blobs to blobs with eyes to the wiggling alvin we see today. This video is going to help you strengthen your skills as a scientist in training. You will observe how salmon develop in the eggs and also learn how to use temperature and some math that our friends Yakama Nation Fisheries and other hatchery programs use to figure out the date that salmon will begin to hatch. Even when we were able to see the salmon growing in person at our school's tanks, there's a lot of stuff, little moments and very exciting developments or changes in the salmon eggs that we miss. Here you can see they actually move quite a bit inside the eggs. Under a microscope, this is a species of killifish, native to parts of Florida, Mexico, and Cuba. These clear eggs give us a chance to see what life in a fish egg looks like when it's close to hatch time. You can see them gulping, using their gills. You can even see a little heart beating. Just out of curiosity, did you observe anything that made you think the eggs were getting close to hatching? Here is a freshly hatched Chinook salmon that lived at Newberry Elementary a few years ago. Look right below their face very closely and you can see their heart beating. This photo shows how salmon develop from that newly fertilized green egg stage all the way to alvin. We can actually observe when our salmon are close to hatching if we know what to look for. Starting with the green egg, or blob with no eyes, we don't see much, which tells us this egg is far from being ready. But as time goes on, we see the eyes, head, spine peeking out, then veins and speckles on skin. Even the color of the egg seems to change and get a little brighter. You may have seen the eggs bouncing around or baby salmon swirling inside. These are great signs that hatch time is very close. Back under the microscope again is a species of fish you may have seen at a pet store or aquarium. These are zebrafish, growing to hatch in just one day. In this time-lapse clip, you can see the incredible and tiniest changes that happen in the egg. Like salmon and even humans, we all start out as a single cell that divides and multiplies over time, clicking together like building Lego into the cool and complicated critters that we are. This clip also shows how the egg membrane, or shell, gets thinner to make it easy for the tiny fish to break out. This causes the shape of the egg to look something like an ice cream cone or even sort of lumpy as they move around inside. Let's review what we just learned to look out for to know our salmon are ready to hatch. We'll start seeing buggy little eyes, the head, whitish spine, maybe even gills. Color becomes brighter, veins and yolk sac are much more noticeable. The eggs will be bouncing or wiggling around. And don't forget about maybe that ice cream cone shape or lumpy. At this time, pause the video and open up your Schools for Salmon packet. If you don't have it, you can follow along using a notebook and pausing the video when you need to write things down. On the lesson webpage, you can look at the sheets that I'm showing you right now. We now know what to look for to know when our salmon eggs are close to hatching. So let's use math like the pros at the hatchery to learn the exact date to expect the fun to begin. Knowing when to expect the hatch to start is very important to hatchery managers since fish have to be moved to different tanks and ponds as they grow bigger. Temperature is going to be very important for our calculation. Salmon are cold-blooded animals. That means they are very sensitive to the temperature of their environment. Similar to how things seem to slow down in nature during the winter, salmon will either grow slower when it's cold for them or faster if things get warmer. Here you see a safe temperature range for salmon eggs. That is any temperature between 5 and 9 degrees Celsius. Closer to 5 degrees and they will grow slowly, but up around 9 degrees, their cells will work faster and they will develop quicker. To get a better idea of how salmon grow and develop, depending on the temperature, let's do a little investigation. I want to show you a salmon that's growing a different amount each day over 7 days. Can you tell on which day the water got warmer? Here's a hint. We know salmon grow faster when their water is warmer, so look for the day when they grew a lot. On days 1, 2, and 3, our salmon is growing slowly, a little bit each day in colder water. But here on day 4, our baby salmon grew much bigger and in only 1 day. This is the day the water got warmer. On days 4, 5, and 6, the salmon keeps getting bigger and growing more in the warmer water. But wait, on day 7, it looks like the salmon is almost the same size. What do you think happened on day 7? Our salmon seems to be growing now much slower. That must mean the temperature on day 7 got colder again. Keeping track of water temperature every day will help us do our hatch prediction math. Ready to learn how the pros do it? Let's start working on that prediction calculation to see when the eggs were expected to start hatching. To start our calculation, we need to know the day the eggs were fertilized. This is the first day our salmon started to grow and develop, and this would be the first day we start recording the temperature for our math equation. Our eggs were fertilized at the hatchery on November 29th of this year. Let's write this into the blanks on your data sheet or in a notebook. Below the date it says, on this day, the salmon eggs have no 0 ATUs or accumulated temperature units. Every day they should grow if the temperature of the water is between 5 and 9 degrees Celsius. We will keep our tank at 5 degrees Celsius. So we will add 5 ATUs growth every day. Wait. ATU? What's an ATU, you might ask? Well, I'm glad you asked and pleased to answer. ATU stands for Accumulated Temperature Unit. Pretty fancy words, huh? Accumulate is a word you might hear weather people say on the news when talking about snow or rain. Used like this, it means that snow or rain may accumulate or the amount of it will get bigger over time. Accumulated Temperature Unit, or ATU, is a number we will calculate for our salmon that, like them, will grow bigger over time, and like what we learned in our investigation, how fast they grow will depend on the water temperature each day. I know this sounds a bit tricky, but let's think of using ATU for salmon like we use age. Both are units of measurement describing growth and development. At birth, we are just starting to get older, so we are 0 years old. Sounds weird, huh? So, at 0 years old, you're actually just called a newborn. Many years later, we have grown a lot, and at 18 years old, you are considered adult. Each species of salmon has a special ATU number that tells us what stage they are in their development. This chart shows the different ATU numbers and what stage the salmon is at when they reach that number. I circled that coho start to hatch at 400 ATU. I wanted to show you what they actually look like at each ATU stage. So at 0 ATU, that green egg, little blob, at 220 ATU, they're called eyed eggs. At 400 to 500 ATU, that's hatch time. Each one of these happens at a different time. 0 ATU at day 1, 220 ATU 30 days later, and almost 3 months later, which is 90 days, is when they're about to hatch. To figure out the ATU, we need to add together 2 numbers every day. 1, the temperature that you observe in the tank, and 2, the ATU from the day before. So this day 1 that I just showed you is what happened on November 29th. The egg was fertilized, so the ATU always starts at 0 on day 1. Now on day 2, this egg was kept at 5 degrees Celsius. So we look back at day 1 and see that ATU was 0. Add 5 from the temperature to the number 0 from the day before. 0 plus 5 equals 5. On day 2, November 30th, our eggs had 5 ATU. Day 3, on December 1st, the temperature was still 5 degrees. We look back to the last day that was 5 ATU and just add the temperature number to that again. So 5 plus 5 equals 10. Day 3, our salmon have 10 ATU. In real life, the temperature will change sometimes and stay the same others. Like I showed you in your investigation, all you need to do is add the temperature each day. And if it's warmer, the number will grow bigger sooner, meaning the eggs will hatch sooner. If we keep it colder, the eggs will hatch later. Back on your data sheet, the next blank we need to fill is how many ATUs did our eggs have on January 1st. I did the math for you for this part, and here's what I did. Each day, I took the temperature, wrote it on my calendar, and added the number to the day before's ATU. Lucky for me, the hatchery kept the temperature at 5 degrees Celsius every day. Science magic! So you can see on my calendar, from December, I added 5 each day And by January 1st, the ATU grew to 165 ATUs. So that is what I'm going to write on my data sheet. By now you know the eggs were fertilized and began to develop on November 29th with 0 ATUs. That 0 got bigger each day, and on January 1st, it was 165 ATU. Let's take that number and write it on your calendar. We just learned that coho salmon start to hatch at 400 ATU. And since we are almost to 200 starting January 1st, I got you pretty close. I want you to do exactly what I did, and on your calendar, I want you to keep adding 5 degrees and the last ATU to each day until you get to 400. Once you add up to 400, circle the date it happens on and try to draw what you think the hatching salmon will look like. This will be your estimated hatch date, or the day we would expect the salmon to hatch if they lived in 5-degree water every day. Please pause the video now. Restart it when you know the date our salmon are supposed to hatch at 400 ATU. So what do you think? Did the date you circled surprise you? If you remember seeing the fish starting to hatch before this lesson, was that date correct? What would be the reason the circled date is late or early? And if it was, what does that tell you about the temperature of the water? And my last and big final question, even with powerful math and observation skills, is nature always predictable?